The reason of analogies in physics. First part. Introduction. The comparative study of the main physical theories of the microcosm highlight the existence of a common mathematical structure. This common mathematical structure is revealed by the existence of analogies between different physical theories. We will show that the analogies are consequence of the fact that each physical variable of whatever physical theory is associated with one of the four space elements, such being the volumes, the surface, the lines, and the points. It follows that, considering two physical theories A and B, to each variable of the theory E, it corresponds that physical variable of the theory B that is associated with the same space element. This correspondence, based on geometrical consideration, implies that the operation usually performed on any variable of the theory A are also performed on the corresponding variable of the theory B. This implies that each equation of the theory A it corresponds a similar equation of the theory B. In fact, it is a similarity of the equation of the two theories that puts on light the existence of analogies. What is the reason of analogies in physics? Well, by comparing the physical theories of different physical fields, we are often struck by the similarity of the equations that describe different phenomena. To give an example, the Poisson and Laplace equations are encountered in electrostatics, heat transfer, fluid dynamics, liquid membranes, diffusion phenomena, gravitational field. All these are different theories in which the Poisson and Laplace equation appear. Then we ask a question: how is it possible that theories that deal with very different phenomena are governed by similar equations? Well, we propose to show the origin of analogies. To find the reason of the existence of analogies in physics, we must focus on the definition of the physical variable that appears into equation. We wonder, despite their different physical content, do the physical variables share some common characteristics? To give an answer, it is opportune to distinguish between the variables that are density of other variables from those that are not. We will call global those variables that are not the density of other variables. An examination of the global variables highlights that each of them contains, in its very definition, a reference to one of the four space elements, such being volumes, surface, lines, and also points. These are the four space elements. To give a list: mass, electric charge, entropy, entropy production, energy, momentum, weight are physical variables associated with volumes. The electric charge contained in volume, the entropy of a region contained in a system, the energy in a volume, the flux of matter, of energy, of electric charge, the flux of entropy, the electric flux, the magnetic flux, the vortex flux, and so on, are all associated with surfaces. The work of a force, the electromotive force, the magnetomotive force, the velocity circulation are associated with lines. Temperature, displacement, electric potential, gravitational potential, well, are associated with points. As you see, we have here a set of physical variables that have a different association to space elements. We will say that the global variables are associated with space elements. We use this term associated in a specific way. The corresponding density, the line density, the surface density, the volume density, inherits the association with the same space element of its global variable. Consequently, by comparing two physical theories, we are brought to compare those physical variables that are associated with the same space element. The origin of analogies in physics deals with the fact that in different physical theories there are physical variables that are associated with the same space element. We may organize the four space elements on two columns. On the left columns we put points and under them lines here, points and lines. On the right column we put surface and over them volumes. In order to represent the physical variables that in a given theory are associated with each space element, let us put laterally four elliptic boxes. In each box we put the corresponding global variable, denote them A, B, C, D. Hence we have in this way a first diagram for classification of the physical variable of a theory, taking into account the space element to which the physical variable is associated. The relation between the four variables are expressed by equation that we put in three rectangular boxes. The link between the variable A and the variable B is expressed by an equation. And the same is for the variable B and C and for the variable C and D. Or two different physical theories. The analogies are clearly shown. Here you have the diagram of the first physical theory, and here the diagram of another physical theories. Well, in the first there are the variable A, B, C, D, a small character. In the physical theory, capital A, capital B, capital C, and capital C. Well, as you see, one can easily see the correspondence between the variables and automatically the correspondence between the equation that links the variable. The equation on the left side here corresponds as the same shape of the equations that links the variable capital A and capital B. And this is the same for the corresponding equations. Well, let's examine now the physical quantities. Why does mathematics enter into physics? Physics, compared with other natural science, has many quantitative attributes. And this leads us to introduce physical quantities. For each physical quantity, once we choose a unit of measurement, its value is expressed by a number. And with numbers, mathematics makes its triumphal entry into physics. Hence, the quantitative attribute gives rise to physical quantities. The physical quantities is expressed by a number. Moreover, quantitative attributes are expressed by numbers. we have to explore the following theories of physics: mechanics of particle and of rigid bodies, mechanics of deformable solids, fluid mechanics, acoustics, thermal conduction, electromagnetism, optics, irreversible thermodynamics, and gravitation. As you can see, these are in practice all physical theories of the microcosm. The mathematical description of physics is based on the existence of physical quantities. Here we have put in alphabetic order the main variables of different theories. Here you may have mechanics, the displacement in force, mechanics of solids, for example, the strain tensor, the stress tensor, the bending moment, the mechanics of fluid, the mass current, velocity, viscosity, vorticity. In electromagnetism, we have the electric charge, the electric potential, magnetic flux, and so on. In optics, the phase, the frequency, the wave vector, the wavelength of radiation. Physical quantities are the main actors in physics. In order to understand their role in a physical theory, we should analyze their physical meaning and how they are linked with the space elements. The traditional classification of physical quantities. Physical quantities can be divided into three main classes. These are the fundamental constants, the physical parameters, and the physical variable. These are the three classes in which usually we divide all physical variables. The fundamental constants are quantities which maintain the numeric value in any situation. For example, light speed in vacuum, the Avogadro number, the Planck constant, the gas constant, the electron charge, E. The physical parameters are quantities that characterize a system or a material, and these are system parameters, material parameters, coefficients, factors, modulus. For example, the Young modulus in elasticity, the electric conductivity, the thermal conductivity, the viscosity of a fluid, the resistivity of a material, the stiffness of a spring. The physical variables are the quantities that describe the configuration of a system or of a field, the source of a field, the energy content and the energy flow, and so on. Examples are the pressure, the potential energy, the magnetic flux, all these are physical variables, the temperature, the work, electric charge, and so on. Hence, this is a first well-known classification of physical variables. Now, we show how, taking one theory of physics like mechanics of particle and rigid bodies, we might divide the physical variable in these three classes. The variables here are put in alphabetic order. As you see, some of the main physical quantities is a parameter, some other is a variable, for example, the moment of inertia of a body, the static moment of a body, the stiffness of a spring. Here you have the division. They are not fundamental constants. Let's give a look to electromagnetism. Also here the variables are put in alphabetic order. Some of them is a parameter, and some other here is a fundamental constant. permeability in vacuum, permittivity in vacuum, Pointing vector, the speed of light. Here you have the division into three classes of the main variable of electromagnetism. For solids, you have here the analogous distinction, and here we don't have fundamental constants in mechanics of deformable solids. Now we pass to fluid mechanics. Also, in fluid mechanics we don't have fundamental constants, but we have physical variables and parameters. Well, physical parameter is equivalent to physical constant. It's also called physical constant or parameter, even if in some material or in some circumstances it is not constant. For example, the mass density is a constant in a solid and is variable in a gas. The refraction index in a gas depends on its density. The specific heat of a solid, for example, depends on the temperature. The boiling temperature increases with the pressure, hence we have few parameters that may change, may depend on some other variable. But in general you can find these in the booklets on physical constants. Physical variable, this is a peculiar factor, are endowed with sign. There is an important distinction between physical variables and physical parameters. The physical variables are equipped with sign, then they may be positive, zero, or negative. The physical parameters have not a sign, and their value is zero only in some limit case. For example, an inviscid fluid has null viscosity, a superconducting material has null resistivity. Thus, given a thermodynamic system, the heat is a positive when it enters the system, it is negative when it leaves the system, and it vanishes when the system is contorted, bounded by an adiabatic wall. So considering an oriented line and a particle moving along the line, its velocity is positive or negative depending on whether its direction is concordant or discordant with the orientation of the line. It can also be zero if the particle is at rest. For now on, we shall consider mainly the physical variables. Our goal is to prove that the study of different branches of physics, both pure and applied, in particular the various fields of engineering, is made easier if we classify the physical variable according to the spatial element with which they corresponding global variables are associated. A new classification of physical variables. Up to now, we have said that physical quantities can be divided into three main classes: the physical quantities, fundamental constant, parameters, and variable, and this is a traditional classification, and happily is not taken into much consideration in books of physics. It is obvious, but is left implicit. Well, even the physical variables can be grouped into three main classes. These are the configuration variable, the source variable, and the energy variable that we shall present in a moment. Configuration of a system indicates a simultaneous position of all the parts that makes up the system. So a book can be placed on a table or on a shelf. It can have different positions. It can be open or closed, lying down or standing, so it can have different configurations. A dancer might be in a different position on the stage and can take different figures, which means that with her body she can take different configurations. You can extend the term configuration to a field, so the distribution of the temperature in a pot can be interpreted as a thermal configuration. A classification of physical variables. In every physical theory of the macrocosm, the physical variables belong to one of the following three classes: the configuration variable, the source variable, and the energy variables. Between the source variable and the configuration variable, there are the constitutive equations, as we shall clarify now. The equations that link a source variable with a configuration variable are called a constitutive or also material equation, because contain physical parameters that describe the constitution of the material medium. Well, let's define the configuration variable. These are the variables that describe the configuration of a field or of a system, and those related to them by operation of sum or difference, multiplication or division by a length, an area, a volume, or a duration, and by the operation of differentiation or integration, without the intervention of physical parameters. Belong to this class the geometric and kinematic variables of mechanics. The most important member of the family of the configuration variables in each theory is the one associated with points. The first at the top of the left column of the diagram. This is the potential of the field. Now, let's give a list of examples. In mechanics, you have the position vector, displacement, velocity, and so on, the angle of position, the angular velocity. All these are configuration variables. In particular, position vector, the angle of position, angle of rotation are geometrical variables. On the contrary, the displacement, velocity, the angular velocity are kinematical variables. In continuum mechanics, we have the displacement, the relative displacement of 2 points, the displacement gradient, the strain tensor, strain rate tensor, velocity, velocity potential, vorticity, volumetric strain. Not only they, there are some other variables, but these are configuration variables. Partly are geometric variables, partly are kinematical variables. In electromagnetism, you have the electric potential, the electromotive force, electric field strength, magnetic vector potential, magnetic flux, the magnetic flux density, and these are the main configuration variables of electromagnetism. In reversible thermodynamics, you have the temperature gradient, the chemical potential. In gravity, the gravitational potential, the acceleration of gravity. Hence, these are the main configuration variables of different theory of physics. Now, let's define the source variable. These are the variables that describe the source of a field or of a system, and those related to them by the operation of sum or difference, multiplication or division by a length, an area, a volume, or a duration, and by the operation of differentiation or integration, without the intervention of physical parameters. Belong to this class the static and dynamic variables of mechanics. These are the source variables. Here we list the main source variable of different physical theories. The force, the primary physical variable of the source kind of mechanics, and as the time integral, the impulse of the force, momentum, the torque, the angular impulse, angular momentum. In continuum mechanics we have the surface force, the volume force, the stress vector, the stress tensor, pressure, the viscous stress tension. These are source variables. In electromagnetism we have the electric charge, the electric flux, the electric displacement, electric current, magnetic strength, magnetomotive force. In reversible thermodynamics we have the entropy current, number of moles, entropy production, entropy source. The gravitational mass in gravity. In fact, the gravitational mass, the mass is a source of the gravitational field. Well, third class, energy variable. The energy variable are those obtained by the product of a source variable and a configuration variable. Work is a product of force times displacement. Power is a force times velocity. As you see, force is a source variable, displacement and velocity are configuration variables. For example, the gravitational energy is a product of weight times 8, in proximity, of course, of the earth. Kinetic energy is 1/2 the momentum times velocity. The enthalpy is the internal energy, that is another energy variable, plus the product of pressure times volumes. The electric energy is charge times potential. Heat is the increase of entropy times temperature. In all these examples, you see that the energy, an energy variable, is a product of a source variable for a configuration variable. Of course, we have used the colors because nature also uses colors. The trees are in green, the sea is in blue, the earth is in different colors, brown, yellow, and so on. And colors may also be used to describe whatever theory, and then it can also be used in explaining physics. The three classes of physical variables as summary. Here you have a list of the main physical variable of the configuration kind. The position vector, displacement, velocity, the angular velocity, the strain tensor, the vorticity in fluid dynamics, the cubic expansion rate, electric field vector, electric potential, magnetic flux, the gravitational potential, the acceleration gravity, the temperature. All these are configuration variables. The source variable, force, impulse, momentum, angular momentum, the stress tensor, entropy, pressure, all these are source variables. Mass, density, electric flux, electric current. And energy variable, work, power, the potential energy, the kinetic energies, internal energy, heat. The enthalpy, the free energy, gives function, and so on. The Lagrangian, the Hamiltonian action, pointing vector. These are the main physical variables of different physical theories divided into these three classes: configuration, source, and energy variables. Summary of the lecture. The mathematical structure of physics starts with the existence of physical quantities. Physical quantities can be divided into three classes: the fundamental constant, the physical parameters, and the physical variables. In turn, the physical variables can be divided into three classes: the configuration variable, the source variable, and the energy variable. The energy variable arises as product of a configuration variable for a source variable. Well, tips for students. Consider the physical quantities that you remind and write them in three separate lists based on the criterion 2, divided by fundamental constant, physical parameter, and physical variables. Analyze the written quantities and divide the physical variables only, writing them in three separate lists based on the criterion 3, configuration, source, and energy variables. Well, here we have a statement of Albert Einstein. The true value of a human being is determined primarily by the measure and the sense in which he has attained the liberation from the self. Albert Einstein. This is the end of the first part.